Well, hi, good morning. Thank you for joining me in my shop and keeping me company while I work on this radio. The first thing I'm going to do today is I'm going to change the one filter capacitor I installed yesterday because the radio's B plus voltage is a little higher than I was guessing. So I'm going to change out this capacitor and put in this one. This is a 10 microfarad, which is the right size according to the schematic, and it's a 350 volt capacitor, so I think it'll withstand the situation a little better. That's the first thing I'm going to do, and then what are we going to do? I don't know yet. Not a lot of parts in this radio, that's for sure. So we can kind of separate this a little bit, and we can say audio end and radio end. The radio seems to be weak. Its reception seems weak, so I would be suspicious just on the face of it. One of these three, or all three of these, are involved with making the radio weak. Do I know that? No, I don't know that. But I've tried to set things up so that as I change these capacitors and test the radio, we can tell when one of them is makes a big difference. Why don't we look on the schematic? I can tell you right now, this one's carrying audio from the volume control. Excuse me. So that leaves these two wax capacitors. That's not very much at all. The mica ones I'm not concerned about. They're almost always just fine. And looking up on top, sometimes there's a capacitor up near the antenna coil. There's nothing. That's it. Two capacitors. Okay, well, that makes it easy. One of them is tied to this coil, which I believe is related to the local oscillator, and this other one is connected to, this is the first tube, and this side of the capacitor is going to ground here. This is a grounded terminal. Why don't we look for this guy and see, well, look for both of them really. Can't read the size. They've got it hidden from view, so let's look on the schematic, see what we can figure out there. Okay, the wax capacitors are not marked distinctly in some way, but you can just tell from the size. Like here's a 0.01, that's coming off the volume control, we saw that one. And looking around, here's a 0.05. This one is connected oh, what's going on there? I'm sorry, this looks like a screen supply here. That's what this looks like. Okay, definitely a screen supply. So this is an important capacitor. 0.05 is kind of small for the job it has. And then there's another one right here, 0.05, right off the antenna coil, between the antenna coil and chassis ground. This is the one we should do first. See what happens. I believe the job of this, and again, it's just me talking, you see the ground here. And of course the capacitor looks like a small resistor or short circuit at radio frequencies. So this ground from the radio signal's point of view is sitting here. And what that would do is that would ensure that any energy that gets developed in here from the transformer primary is locked inside here. It's all in here. There isn't some of the energies wasted on this resistor back here or something of that sort. You sort of focus the action here, if I can put it that way. It's probably a stupid way of saying it, but take this away and I think the radio would lose strength. And so how would you take this away? Put a weak capacitor here. It would take away the ground. That's my thinking on that. So let's do this one first. 0.05, it should be easy to spot. It's going to this coil. Oh, this is the coil I thought was the oscillator coil. Okay, so I'm guessing maybe the coil up on top is this one, the oscillator coil or transformer. Okay, that's the guy we want to get to though, right there. Grounded at one end, other end in the coil. Grounded at one end, other end in the coil. Here's a coil or transformer. Here's the capacitor. That's not grounded. Is it? No, I don't think so. The resistor this way. Got a wire going up. Oh, yeah, wire going up. Up to here on this outside coil. That doesn't match. That does not match. Wait a minute. This wire. I looked at this wrong, just from the angle of the wires here. This capacitor is tied to this terminal, tied to this wire. This wire runs over and ties right to the chassis. So there we are. So this is the guy. It's just looks kind of weird. Oh look, see, there's a wire that goes from this terminal up to this coil. So this capacitor, although it's laid up against this transformer, this is just a ground terminal, and really it's wired up to this coil. Okay. None of that really matters. I'm just going to replace it. But it is the capacitor that I'm after. Before I do that, because I've learned from experience, as soon as you cut away the component, you can lose track of where it came from. I can anyway. I'm pretty good at that. So I put a clip lead on to make sure I don't lose it. This capacitor looks okay, except the wax is really dry on it. Oh, a little dirty on the underside. Philco 0.05, made in the USA. 200 volt. 200 volt 0.05. We will test this. Let's test it right now. Let us go to the tester. Okay, just let me do an untangle maneuver here. There we go. The thing about this kind of tester is it puts a high voltage on that capacitor, which is what happens in these old radios. It doesn't happen in new transistorized equipment. So the idea of testing a capacitor by applying a high voltage to it is an antiquated idea, really. But if you don't do it this way, like I think if you put this on a regular, more modern tester, it'll give you some values. But frankly, I don't know how to interpret them. This is easy to interpret because you put some voltage pressure on it and you can see if it leaks. It's quite straightforward. Okay, voltage pressure. And I just wish I could get the lighting a little bit better so you could see the pi easier. So here we go, 50 volts. And just barely cracked open. Not, it looks nice, not nice. So I've done lots and lots of capacitors this way. And I can tell you this one is poorer than average. Just leave it there. Poorer than average. So I gotta get a 0.05, I gotta get 2 0.05s in fact. To go in here, 200 volt, 0.0, I think I'm very low on 0.05s. Okay, two capacitors in. I don't know, could this make a difference? I think it could. So we're gonna play it on the antenna. You can see it's connected here. Let's see if you can remember from the last video what this sounded like. Here we go. That was me switching off the dim bulbs and switching straight onto the outlet. Only 100 volts. Here it comes. 105 volts we're feeding it. Very poor. Poor reception. Have to be careful about getting a copyright hit if I have music. Poor. Obviously this string situation is not working out. Oh, here we go. Knob, I believe the knob is turning backwards. Like, I'm turning my hand this way. I'd like to see the pointer go this way, but it goes the other way. That's two reasons to do the string. I have to do something because it is no good. So I've heard another radio that picked the same stuff up in this area here. Okay, not working well, that's for sure. Maybe before I do more capacitors, I should eliminate the vacuum tubes as a potential cause of weakness. It's very likely. That's a possibility. So maybe, well, what have we got? We only have one more capacitor to do, really. Only one more in the radio side of things. We should just do that. Do that one. And be done with that. This is an audio one, and this is also this is off the plate of the output tube, and this is designed to take away harmonics that may have been produced along the way. So this is audio. This is the only one that's a radio type capacitor. So let's go ahead and do that one. Jim, turn the power off. Don't forget. I'll cut this out and test it. And then take a coffee break. 0.05. Made in the USA. I don't think they're making capacitors in the States anymore. Okay. Maybe they are. Maybe they will once again. Okay, 50 volts on the capacitor, watching the eye, not opening at all. So, you don't look so bad, but you are bad. That's a baddie. Now, I mean, its purpose, what was its purpose? What was its purpose? Let's take a look at that. So it's hooked up, oh, I didn't put the other clip lead on. Jim, don't do stupid things like that. Oh, you dummy. I think it came from down here. Duh. So this is a grounded terminal, and so that is where it's coming from, and that is pin number 1, 2, 3, 4. Pin 4 on, what is that, 6A8? Pin 4. Let's take a look. Yeah, 6A8. Pin, oh, right, pin 4. Well, we'll look for the capacitor here. These are adjustable capacitors. That says 110. I think it says 110 microfarads is what it says there. This is it here. It's attached to, yeah, this is the screen guy. Okay, we'll replace it. The screen guy. The small. Okay, second one's in there now. That's it for wax capacitors in the radio portion of this radio. Wow, not many parts at all. Congratulations to the engineer. Okay. 10 is there. Something's humming. I think it's the transformer. I think we have higher volume here. Oop, not there. Well, that sounds better, I think. So it's the AVC capacitor on the AVC line. Wasn't that what I just did? And I guess if it's leaky, it's going to draw down the charge in the grid circuit. Perhaps throw the bias off and not allow for proper operation of the AVC if it's leaky enough. Let's see if we can get way down here. So I don't think we could pick this station up before. I don't think there was anything happening down here. And now we're getting some stations. It's quite a dirt spot in this. I could try to, oh, the level just changed. Okay, what to do next? I think round of tube testing is in order. I'll save the string repair for later in the game, the string replacement, and yeah, we'll run these tubes through the tube tester. We'll see what we get, and that will be the end for today. Great, coffee time here. Okay, let's start at this end and work our way across to here. So this is the rectifier tube, which I shouldn't even bother testing because it's working in the radio. It's a 4-pin, it's probably an 80. Yes, it is. It's an 80. So rectifier tubes like this and output tubes like the one here wear out. Actually, it's here. The output tube is here. They wear out faster than the other tubes, and so they become much more rare than the other tubes. So protecting rectifier tubes and output tubes, important thing that we should do. I think I need to plug this in. Okay. So we'll dial up number 80 here. It's going to be over here. 50, went past it. number 80 right here. Filament voltage is 5 volts. Rectifiers have 5 volt filaments. No need to set this, no need to set the bias. And the magic numbers are 73P00, 73P00, and 6,000. 6,000. Okay. Sensitivity is set to 25. Make the meter accurate. Voltage is set, plate voltage set to E. So over here in the remarks it says F, P1, P2. So the F is a indication that when I do the test, it will show a short on pin 1. When I do the shorts test, it will show a short on pin 1. P2 and P1, P2 is this switch here. There's two, well, you can tell that there's two things going on in this tube. So there's plate 1 and plate 2. I test them separately. Okay, everything good to go. 73P00. I don't trouble check this stuff. 73P00, 6,000, 25, and E. Okay. So of the 4 pins, 2 of them are fat. Often there's an arrow that indicates it. There's no arrow on this one. These 2 are the fat ones. The fat ones over right there. Go! Okay, I can see the elements, the heaters coming on. Give it a moment. So the first test is to look for shorts between the tube elements, and to some degree that's to protect the tube tester, because you do not want to test a tube with a short in it. So this is the shorts test. We're watching the meter here to see if it comes up. The meter might be a little hard to see in the camera. And on number 1, it should go all the way over, which it does. Normal. Okay, we're set for tube test. In this case, we're pushing this switch, rectifier and diodes. Rectifiers have to come up this far. There's a little area here that says rectifier's okay. As long as we get above where my finger is, we're good to go. Okay, that's one side. Here's the other side. Good tube. No surprise there. Okay, so on next tube, is this one here. This is a Loctile tube. So I've learned how to do this. To remove a Loctile tube, you look for the rivet that's holding the socket in, and you bend the tube towards the rivet. And it should pop out like that. 7B5. Okay. So most tubes, the first number actually indicates the heater voltage. So a 6 AU6 has a 6 volt heater in it, 6.3 volts actually. These ones have a 7. The 7 doesn't mean anything special. It's the same as a 6. This is a 6 volt tube. The 7 is to keep them, because of the unusual base here, this Loctile base. So all these ones with this unusual base start with the number 7. Just to keep track of it, just to sort them out. Okay, so we look up a 7. We're going to get there this way. 7, here we are, 7B5, wasn't it? And plus, on these Loctile ones, they tend to write the numbers right on the top. 7B5. Oh boy, I can hardly get there. There we are. Okay, 7B5. There's 2 tests for it. So first, 6.3 for the heater voltage. Signal level 2. The bias is 46H. H, I think, stands for high. The numbers are 73400, 73400, 5160, 5160, 40 F. But the easiest mistake you can make in doing this stuff is reading off the list here and accidentally shifting down a row without realizing it. and reading the wrong values for another tube and sticking it in. That's the easiest mistake to make doing these tube tests, I find. So 6.3 volts, signal level 2, 46H, 7.3, that's why my finger's like this, by the way. 73400, 73400. That's to make sure I don't see the other numbers. 5160, 5160. Okay. We're set. 40 F. Now, where's the socket for these guys? Oh no, my tube tester doesn't have a lock though? Oh, here it is here. Okay, because it doesn't lock the lid on the tube tester. But I did see the light flicker, which means the heater's taking some current. Give it a moment. Are there any special notes here? 7B5. No. So what we're looking for is a reading of 680 when we do the test. That's 1,000. That's 500. So 680 is about here. So the needle's got to get up above here when we do the test. But first, are there any shorts? Again, it's not very likely, because if there was, I think we'd know about it already, because it would show up in the radio. Okay, so we're going to push the GM test, and we'll look for it to come above here. Way up above there. She's lovely. That's a lovely tube. Beautiful. Okay, put it back in. So the next tube is a metal tube. Remember, the wire came off the grid cap. What I've done here is probably the best thing you can do. I just kind of shove it in and shove it on. You can't solder these to here. Well, you can try. Okay, let's get this tube out. Hey, that other tube had 2 tests, didn't it? Wait a minute. Hold the fork. There was another test. Okay, we've got to complete this properly, because a little surprised there's another test. Am I right? 7B5. There is. Okay, we're in. Oh, I shouldn't have this in right now. So some tube testers, you can adjust all these controls with the tube in, and others you can't. If you do, you can end up in trouble if you work these controls with the tube in. Then I don't know about this one, so we won't risk it. So 6.3, we're testing a diode, so there's no need for this, no need for that. 70003. 7003. 7003. 70003. Okay. And P160. Can you hear my cat growling? P160. Sensitivity 48. Plate voltage way down to A. There's 2 plates. There's 2 diodes in here. Okay. Boy, it does not feel good. It's in. A moment. Yes, a lot of cat growling this morning. You see my black blob down there is my other cat who you seldom see. She does not get along with my orange cats, my wonderful orange cats. So there's consequently a lot of growling that goes on. Okay, looking for shorts. Always good to do this. This time we're flipping this button here, rectifier and diodes. The diode test only has to come up to here. We got nothing on that. Okay. 70003. 70003. Yeah, I did get that right. P160. P160. A was a P1, P2. So we've done one side. Nothing. What's going on in this radio again? Maybe it's loose tube contact. Doesn't seem to be the case. Well, this is suggesting there's a diode not functioning in this tube. Let's take a look at the schematic here for a minute. So the tube we're testing right now is 7B5. Why would there be two tests? There's something going wrong here. Something is not working out right. It's definitely a 7B5. I can read the numbers very clearly. It's definitely a 7B5. Something's going wrong because I'm testing it as if there's diodes in it. There's no diode in here. 7B5. Well, I'm going to stop for a minute and drink some coffee because something weird is going on here. It's probably me. So it looks like there's an error in my tube tester information. So we're going to take a closer look. You see the camera on top of my tube tester. This is what it's looking at. Well, let's just see where my mistake is. So this is a, you can hear my cat complaining, 7B5. Does anybody doubt that? 7B5. Okay, then we come down here. Okay, 7B5. It doesn't say 17B5, does it? Can't. 7B5. And there's two tests, and one of them is a diode. But there is no diode in a 7B5. Oh my gosh, what's going on behind me? So I think the tube tester is wrong. Bold statement. What's going on here? Oh! That black cat, I tell you. Shadow, come here. What's with you? How come you don't like those guys? Come on, keep coming. You know, they just want to play with you. That's all. You should lighten up. You'll enjoy your life a lot better. She's not listening to anything I say. Okay, so I guess I got another tube tester out here to really know if this tube is good. I should pull it out of this. Yo, that's hot. That's a hot one. Been in there quite a while. Okay, I'll have to get another tube tester out and see what's up. You know, see, strange stuff happens when you're doing this work. Okay, so we're switching from the Weston tube tester. It was a Weston 981, I think, to this Stark model 966. This was a really popular tube tester back in the day, at least here in Canada. I think these were all made in Canada by Stark Electronics. Okay, good. Now let's see what it says about a 7B5. Right at the end here we are, 7B5. So of course there's only one test, as there should only be one test. I have to guess that the other tube tester, the test I performed, the first test, was correct, and the second line on the tube tester was incorrect. It shouldn't be there. But we'll test the same tube in here, 7B5, and we'll see what happens. Okay, 7B5, so 6.3 volts, JR. These are the heaters. Heater settings, 6237 with a 0. 6237 with a 0. 34 on the bias. 68 on the English. So what it means here by English, if you set the meter control to English, then all you're doing is reading the replace or good chart. Okay, but I'm a little bit smarter than that, so we'll put it on a scale setting of 3000, and the proper throw it away, the minimum reading or the throw it away point is 1010. So on the 3000 scale, 1010 is right about here. So we'd expect the tube to come up in this area here. Okay, so we are set to 6.3. That's correct. Now we're going in right here. Okay. Give it a moment. Let's check the line. So the line adjust. So line adjust is here. Just a touch high. Not that this machine is that accurate anyway. I mean, this is. Okay, so tube should be warmed up. We'll go through the short test. On this tube tester, it's not the meter, it's this light here that indicates a short, if it stays on. Flashing is fine. Okay, didn't do much, did it? So we're going to push the test button, GM test button here, and again, we expect this to come up to 1010. A good, well, like new tube would come up to 1600. So get up in this area, it's just like new. 1010 is here. Here we go. So way up there. So okay, so there's nothing wrong with the tube. Something wrong with that tube tester. That's the situation. We might as well carry on with the 966 here, which is a perfectly good tube tester. And we'll test this tube now. The 6Q7. Okay, 6Q7. So it has a grid cap. Well, I can hold it on. Grid cap. Okay. 6Q7. You have to know your alphabet to make this thing work. 6Q7. We got 3 tests here on this. It's probably a 1 triode and 2 diodes. That's what should be in here. So 6.3 volts, JR 0307 with the 2. So 0307 with the 2. 17 on the bias, 40 on English. This doesn't matter unless I use this English setting, but I set it anyway. Why not? Press P4, 505, throw it away, 800, thumbs up. Can you go? You have to hold this on like that. I don't really need to have it on right now, but I will. Somewhere I have a better cap. I guess it's with the other tube tester underneath. I just put this one on top of the other tube tester. So there we go. Any shorts in here? No. Again, if there was, I think we'd know about it already. 6Q7, this test, P4, 505. So 505 is way down here. There we go. Well above it. Very good. Okay, next test. Next test. So this will be a diode test. 6.3 JR05073. This tube tester, I know you can leave the tube in while you set these. I happen to know that. 0507. Let's find out if it's true. 05073. 17. That's where that is. 0 in the English. We have to have this on English now. Push P1. It has an asterisk after it. Why does it have an asterisk after it? Uh-oh. There's no note here then. What's the asterisk about? Anytime P1 shows up, there's an asterisk. Okay, I don't know why, but don't worry about it. again. 05073. Yeah. 05. Yeah. Okay. Diode. So the diode test is this one here, P1. The diode OK is above here. There we go. Diode OK. And the next test, we just changed the 5 to a 4. Nothing else changes. P1, same thing. Not quite as high, but above. What am I talking about above? I think we just read it good and bad. Let's try that again. So this one's on the edge. Let me go back to the other. I have my knobs loose. This one's a little higher. So question mark. It's in the question mark zone. Oh, I don't have that. Well, this shouldn't matter. Well, let's try it. This shouldn't matter. Yeah, this shouldn't matter. Only matters on the triodes. Well, it's kind of borderline, I would say. So for now, we'll keep that in mind. We have a borderline tube in here. It is the detector diodes. So later, if we still find the performance is low on the radio, we can try changing this tube later. For now, I wouldn't jump at it. So here's another Loctol tube. I'm going to look where the rivet is and bend the tube towards the rivet. Come on. See how that works? It's great. There we go. Alternatively, you could stick a screwdriver under here and kind of, wedge it up and get it out. You don't have to use that technique. When renewing, insist on genuine Philco tubes. I insist. Made in who knows where. The word is gone. Somebody's thumbed this right off. 7A7E. 7A7. Okay, sticking with this tube tester. 7A7. Not sure what the E means. Okay, here we go. JR, first of all, 6.3, right. JR 6237 with a 4. 6237 with a 4. 27 on the bias. 71 on the English. We don't care about it. Okay. We should be looking for 1100 minimum. 1750 if it's like a new. Okay. There you go. This tube's job, I believe, is the IF amplifier, and this one's quite responsible for a lot of the gain in the radio. The IF circuitry is very, how can I say, it's fixed, it's static. It's one frequency, 460 kilohertz, everything is tuned to that, so the engineers can maximize that area fairly easily. Maybe that's why they do most of the amplifying there instead of doing it on the RF stage. And am I right about all this? Look, you know what? These things I say that I have in my head, I think they're right. That's it's up to you. Okay, we're ready now. Shorts. Watching for the light. She's just flashing. Okay. We're going to push P4, and we'll look for it to come above my finger here. So it's above. So she's good. Oh, wait a minute. Yeah, 77, that's all there is. So, would this be responsible for weakness in the radio? I kind of doubt it. Did I not put that in right? I did not. There, wow. Okay, the last one. This is the guy who's most likely the culprit in weak operation. 6A8, a glass version of a 6A8. Now, it's possible the proper tube here looks more like this, and this is actually an older replacement. That radio may have been shipped with this kind of tube sitting here. Vice versa, it could have been shipped. Look how long this wire is. So probably a glass tube was sitting here. You can see the wire's long enough for this to come up onto the glass tube. So this is a replacement. This could be a problem because there's a ground pin that exists here that does not exist with the glass version. How that ground pin, usually pin number 1, is handled in the radio may not be appropriate. For instance, it may be a spare. When you use this kind of tube, it becomes a spare. And so the engineer could use it to make some wire connections, just a spare lug under the radio. Then you pop this tube in, and all of a sudden pin 1 is tied to this metal outside, and this is like an antenna. And what's it picking up? Well, it's picking up everything out here. It's also picking up stuff from inside the tube. So the grounding here is something we should look at. This tube has a little bit of green on the pins. Not often I have seen corrosion on vacuum tube pins. It's very seldom. What happened here? I don't know. Let's check this guy out. He's a 6A8. Okay, just over here. 6A8. 6. Here we are. 1, 2 tests. Pentode section, grid cap, and the other test is the oscillator section. This is a tricky test on the oscillator section, but we'll try it. So here we go. 6.3 JR 0347 with a 5. 3, 4, 7 with a 5. It's kind of weird. This is the grid. Well, maybe having this, I don't know what's going on. This is the grid here. Shouldn't there? Well, I don't know what's going on. Let's just carry on here. Pentode section. Oh, I know what the problem is. This is the grid cap. This is the grid. That's what's going on. That's why this is 0. Okay, I got my act together. 6.3, 20, 22, you haven't finished yet, Jim. 22, and 50. 50 on the English, which won't matter. We're set to the 3000 scale. Expectation is 630, throw it away, 1000, clap your hands. Okay, we'll put it in there. I believe these tubes are getting rare, 6A8 tubes. But they're all getting rare, slowly. And the more of us that are doing this work, the faster the stock of these tubes is going to be depleted. Fortunately, people with tube radios, for the most part, don't operate them for hours and hours every day, as it used to be the case, of course. Now, generally, you're going to operate an antique radio once a month for a few minutes just to show somebody, something like that. So hopefully these tubes will go far into the future. Okay, 6A8. Looking for shorts. I better put this on here. Uh-oh. So I don't know if you can see it, but this is glowing a little bit. And I'm not sure what to make of that. The glow there on 3. Let's carry on with the test. P4 630, right? So 630 is here. Okay, that beeping is my coffee maker upstairs. Did we beep twice? 630. Well, it's pretty close to 630 there. Okay, so that's 2 strikes against this tube now, isn't it? Look at the other part now. 6A8, JR 5647. 5647. 3. 30. 73. One of the reasons this tube tester was so popular back in the day is how fast you can do tube tests. It's straightforward, fairly simple to operate, and highly regarded actually. So okay, so we're ready to push P4, but there's a note here. It says micromos only, OK over 240 on the 3000 scale. OK over 240 on the 3000 scale. So we're on the 3000 scale, and we expect this to be over 240. Well, 240 is way down here. I mean, it's almost nothing here. Here we go. And what am I pushing? P4. Well, that's well above that. So on the oscillator side, the tube seems to be good, and on the amplifier side, not so good. So again, if the performance of the radio remains low, I could consider trying another one of these tubes. Okay, very good. So a radio full of good tubes. Now, most of the radios that I work on, people give me to work on or whatever, the tubes are good. Not always, but most of the time. Once in a while, a radio will come to me and the tubes are correct, but they're in the wrong position. I've had that happen. And I've had it where somebody's decided to fill the radio with tubes that were all the wrong tubes. Just randomly filled it with tubes. So, stuff happens. So, can these tubes explain poor performance? Well, the only answer I can give is, yeah, maybe. Maybe that's the case. Maybe the combination of these two, which two are they? Maybe the combination is a little questionable. Plus, we could always replace this with a metal tube. I probably have some. The older ones are glass, and the newer 6A8s are this way. They're all old. Okay, let's look underneath and see how this ground pin is handled. Maybe first we should look in the tube book, just make sure what I believe is true. So this is a 6Q7 metal, 6Q7, 6QRS. Oh no, what happened? 6Q7. Look at pin 1 is just showing open here. This is probably the glass one. G and GT. What about the kind I've got? Doesn't seem to say, does it? What do you do about that? 6Q7. 6Q7, 6Q7G, 6Q7GT. They're just different glass tubes. Types 6Q7 and 6Q7GT are used principally for renewal purposes. 6Q7G is a discontinued type. Yeah, they're all discontinued type. Listed for reference only. Tubes require octal socket, may be mounted in any position, heater volts, so on and so forth. These types are similar electrically to most respects to the 6SQ7, the 6AT6 maximum rating is typical operation. I'm not going to say anything in here about the pin 1. Recommended resistance come on. Okay, not a word about it. Let's see what's going on with pin 1 under the radio here. Maybe it's just open, and I want to attach it to the chassis. Or maybe whoever put that tube in there did something. So it's this one here, this one here. Let's see what's going on here. Okay, so it's this tube right here. Pin 1 rather than poke with my finger. Pin 1. Pin 1 is right here. This is pin 1, and there's just nothing connected to it. So if I'm right, and this originally was a glass tube in here, pin 1 would be open, available for making connections, but they didn't make any. They didn't make use of the spare pin. But now we have a metal covered tube. You know, inside the metal is a glass tube. It's still a glass tube in there. The metal on the outside shields it, but the metal shielding needs to be grounded. In my view anyway, or my understanding of it. If you don't ground it, it becomes an antenna, and it's right around the tube. So it's almost certain to cause problems. So we could do a temporary thing here. We could play the radio, get a clip lead, clip on here, and stick it on the chassis. That would be the normal place for it to go. You could see what happens. So is it likely to change the performance of the radio much? I don't think so. I don't think so. Interesting stuff. If I was going to stick a clip lead on it and do this experiment, I would stick it on now. That's a little better. Okay, that looks good. So the experiment is, we play the radio, I go like that. Only we're gonna turn this over. These clips have a way, because they're squeezing, they have a way of walking around on things and end up somewhere you don't want them to end up. So I'm being a little picky about this. Okay. I think I got it solid now. I yanked hard on this wire. I did that. Nope, looks good. Okay, experiment is, play the radio and I go like this. And we see what happens. And what I'm doing is I'm grounding this metal can here to the chassis. What do I expect? I don't know. It'll turn into an FM radio. Here we go. We're in business. What happened to the light? What happened to the light? What happened here? Okay, so I mean there's 100. Come on this side. It's a little better over here. 100 volts on it. Maybe this plug didn't quite contact. The light burned out. The light burned out. There we are. It just went to sleep. We are hooked up to an outdoor antenna. I can't remember if it's on or not. I think I switched it on. Well, so much for that. No difference. Okay, no need to worry about that. So from here, there's one more capacitor. That's the audio capacitor coming off the volume control. That's really not of much concern. So probably a little bit of alignment now. We've done the IF. We can do the alignment. It's probably these two adjustments here, and probably another one somewhere hidden away. I haven't noticed. Where's the phono jack on the back of this radio? There's no phono selector. Oh, okay, what just happened? So I still have this clipping underneath. That's kind of crazy. What happened? Okay, is it a tube? You can hear I'm getting my hand close to the tube. Okay, my fingers brushed up against this, but this is pretty solid. I don't know. That's a couple times this has happened now where it's been operating and this performance has jumped one way or another. Like that right there. That was strange. Right off and on again. Speaker doesn't sound bad so far. Let's turn it up a bit. Oh! What happened there? Ooh, what happened there too? What's happening here? It's a pretty sudden click this way and that way. Is that just a coincidence? Not much up here. There's just not much up here to poke at. Wow, we gotta find what... Yeah, we gotta find out what this is. It's the result of turning the radio upside down all the time. Oops, gotta go around this way. Who's the bad actor here? This is not easy to figure out. Could be a defect inside one of these tubes that's clicking on and off. It's possible. Turn it back on. So many things could be doing that. Now I've taken all the tubes out and put them back in. Should be the case that they've all made good contact. Wiggling them hasn't done anything. We know the volume control is wonky. Okay, so is this working good or working bad? So I'm trying to put in sharp shocks, just using the momentum in the stick here, which is very low. This is pretty weird. This is the... oh, 1 second. I gotta run. Okay, back to it there. I was finding out there was something going on just up in here. It certainly looks like a cold solder joint right here. Let me try flexing it a bit. Or contact problem here. But this is the rectifier tube. It shouldn't really... should it? Wow. Sure seems to be a problem here. This is a really lousy kind of tube socket too. This is the sandwich type. And they have two pieces of non-conductive material sandwiched like this. and then they have the holes drilled, for the pins to come through, and then inside the sandwich are the metal pieces that are connecting the pins out to the terminals here. And this arrangement is prone to trouble. You get dirt inside between the two pieces. Bad stuff can happen. Stuff like this, not quite like this. Is it this? I mean, this is the big. This is the filter capacitor. How can it be causing? Well, I guess a loss of voltage. Is that what's happening? The B plus is going up and down. Let me see. We'll see. Couple leads here. Okay, negative to the. Oh, there you go. Negative to the negative. Negative to the chassis. Fine. Positive. Hey, stop. Wait till I get the voltmeter on there. Oh, I just touched it and it went. Oh, that's an indication of a cold solder joint. 200. I can't make it go. Fix it. I fixed it. There, it's fixed. Nope, apparently not fixed. What just happened there? 201. Go down again. It's always this way, isn't it? When you want it to do something, it won't do it. B plus on the clip leads. It's too quick. Come on. I just can't believe the problem would be here anyway. It doesn't make sense. Come on. Well, I don't see the voltage changing at all. There we go. No, it didn't really change, did it? 0.6. Didn't come back. Now you've done it. How can it be here? It can't be here. What else am I pushing on? Well, you know what? I mean, the radio is sitting right on this tube upside down here. I'm pushing away. Maybe I'm just moving the tube around, which is hot stuff. Oh yeah, something going on there. What is it? That is the rectifier tube. Yes, it is. Got 4 pins. I didn't watch this meter. Maybe it's the other voltage I should be reading over here. Let's try that. So we'll go here. 155. Come on. Come on. Backed up. 155. How can this do this? How can this do this? Something grounding out. What are the other pins? The other pins are What are the other pins? I'll take this off. Okay. And that's a high voltage AC lead there, I think. Right on the output of the transformer here. I'm a little scared. So it's 400 volts AC. Now is that changing somehow? I have to put the clip lid on. Let's do this. Just a little scared sticking my fingers down there. Clip lid on. Back up. Will it slowly come up in voltage? Could be it was dragged down while charging these capacitors. Maybe, I don't know. Okay. 455. What do you do? It seems like very loud. Come on, man. Oop. I mean, if this causes a change, a big change, that would be a bad sign. Oh my gosh, I have no idea what's going on here. Okay, we're going to have to ignore it for now until we have a good chance to detect what's going wrong. You know, it could be a component, could be a resistor going open and closing. Could be the capacitor. I got one left here. Could it? But I'm poking here. You know what this means? This means coffee is required. Okay. Other matters have arisen here in my house, and it's now 12:30, so I'm going to call it quits here for today. We'll carry on tomorrow. Don't know what to do about the intermittent problem, but we'll deal with it tomorrow. So thanks a lot for watching, and have a great day.